Good afternoon. Dear mentors, partners, students, followers, and other virtual guests, I hope you now see me as well as you can hear me. Thank you for joining us today at our special PhD showcase, where we will present and literally showcase the work of 7 PhD students here at KInIT. During this first public part of the event, we will present the research and replication studies of our doctoral students through an unusual form of short talks that they have prepared beforehand. We have clustered our 7 students into groups of 2s and 3s, and after watching their videos, you will all have the opportunity to ask them a few questions live, ideally using Slido. Excuse me. You can use the Slido app to pose questions. Visit slide.do. You can see it on the screens right now, and join with our hashtag KInIT PhD. I will then ask all your questions out loud. So a little bit of housekeeping first. After this first part of the event, which is live, and you are watching us either on Facebook or on YouTube, you will be able to join 7 separate online rooms with each of our PhD students and have deeper heart-to-heart discussions with them. In the chat and in the calendar event, you will find the document with links for the separate rooms. So don't forget to use them afterwards, but for now, stay here with us and watch these videos and discussions that we will have now. However, you can also use this live stream to ask a question to any of the students about their work, not only the ones that you will follow up with afterwards. Before moving forward, let me just thank HubHub for letting us connect from its premises. And now, without further ado, let me welcome our first speaker today, which is Daniela Chuda, who is responsible for the management of the PhD study at KInIT. Daniela, the floor is yours.
I am excited to start the first year of our PhD Showcase event. This year, we have our first PhD students at KInIT who are studying and researching their topics from September 2021. In this relatively short time, they have studied with machine learning methods and prepared interesting replication studies of selected research works. Some doctoral students have research topics inspired by industry challenges, some by ideas from top scientists abroad, or by international projects. KInIT PhD program is run in partnership with the Faculty of Information Technology, Brno University of Technology. Our PhD students and their research in this academic year are funded from the state budget by the Ministry of Education, Science, Research and Sport of the Slovak Republic.
Thank you, Daniela. We will start our showcase today with 2 doctoral students who both work with an external mentor from prestigious research institutions in the US. First is Maciej Chiev, who will talk about Netflix, or more precisely about recommender and adaptive web-based systems. Maciej is supervised by Michal Kompan, and his external mentor is Branislav Kveton from Amazon Research. And after Maciej, you will see the presentation of Ivana Beňová, the only female PhD student at KInIT right now. And I hope that this stream is also watched by young women who will widen the girl power team at KInIT. And Ivana will talk about natural language processing, which she studies under the supervision of Marian Šimko and with consultations from her external mentor, Jana Košecká from George Mason University. Let's watch their videos now.
We all use Google or YouTube, Netflix, Facebook, Spotify, Amazon, Instagram, you get the point, many services out there. What they all have in common is that they provide the content to us based on personalized recommendations. There are algorithms that decide what we get to see. Now you could find yourself in a situation where you get some pretty weird recommendations. What's going on there? When a company develops a new recommendation algorithm, they select a small group of customers, and to get a sense how well it performs, it puts the algorithm in front of them. This is called the A/B testing, and you may already see the problem with that. You develop a new algorithm, you want to test it, but you really don't want to put a bad algorithm in front of your users. You lose revenue, you provide a bad user experience, and it can have an even bigger social impact, like spreading misinformation or supporting hate speech by your algorithm, as was the case with Facebook recently. What you ideally want is to evaluate recommendation algorithm without deploying it in front of your customers. There are some challenges, but in general, if you have enough data, you are able to estimate how well the algorithm performs based on logged recommendation data from previous system. And that's where we come in. We are trying to solve a problem of more complex recommendations where you recommend a whole list of items, for example, a Google search result. And with that setup, you never really have enough data, so you have to somehow model the structure of the list. We replicated state-of-the-art estimators for list recommendation. Then we proposed our own estimator that significantly beats the state-of-the-art. But what's more important is that we came to some really interesting findings about the connection between two main groups of estimators, model-free and model-based approaches. In theory, model-free methods have better properties, but they don't really work well with list recommendations, so people use model-based methods instead. But we have found some general ways how to incorporate some of these useful properties, such as weight clipping, into any model-based method and have the best of both worlds. It impacts everyone in this area to be better equipped and have better tools when building models in the future.
What do you see when you look at this image? You constantly recognize what is happening, and words like baseball, players, or guy with a bat come to your mind. You are able to describe this image to someone else, including the colors of clothing or the weather, come up with a story, answer questions someone might ask, or given the description, find this image in hundreds of others. Something so natural for you is called visual language multimodal processing, when we train deep learning models to combine visual and language content. Multimodal processing has many applications, such as helping visually impaired people, understanding images posted on social media and banning the ones against its policy, or just improving your image Google search. Lately, there have been many variations of neural network proposed for this area of research, and transformer-based models had the best performance on tasks like image captioning or visual question answering. However, neural network-based models have one disadvantage. They have millions of parameters, and therefore they appear as a black box to us. We don't know what information they keep or lose, and how they came up with the output they did. We can only check whether the resulting caption or answer about the image is right or wrong. But is that enough? So the interesting question might be if these state-of-the-art models achieved their results thanks to actual and deep understanding of both modalities, or based on wrong impressions. Generating a caption like 5 people playing baseball for previously shown image is a good caption, but not if the model decided that they are playing baseball just because there is a bat in the image. They could be, for example, breaking piñata. So, a good model should combine information about how people stand, what they wear, and how the surrounding looks like. To test this understanding, I follow one of the recent papers and tested whether multimodal transformers pre-trained on different datasets can notice a difference of one word in a caption of image and classify it as no longer matching. By making artificial intelligence understand multimodalities and their context, we can be one step closer to generative intelligence, and with that, closer to operational efficiency and improved decision-making. I believe my work and research at KInIT are going to improve today's state of multimodal processing and move forward our knowledge about artificial intelligence.
And we are back. Thank you so much. So I have Maciej and Ivana with me right now. And I would like to remind you that if you want to ask them a question, you can use Slido. The hashtag is KInIT PhD. And we already have 2 questions. Okay, so both of you, Maciej, Ivana, can you describe how does your work with external mentors look like? What do you enjoy the most? Ivana, you can start.
Thank you for the question. So working with Professor Koszecka is really great. I cannot imagine a better way how to lead new PhD students than by letting them work with experts like external mentors. Every time I have discussion with her, I learn something new. She always has some interesting research paper I should read by hand, and she answers all my eager questions. And she has deep knowledge about various areas and always helping me understand complicated stuff for me. So it's really inspiring for me to work with her.
Thank you. Maciej, we have a question specifically for you. Could you please clarify how well the mentioned MAE measure actually is suitable for list recommendations?
Yeah, for list recommendations or in the area of recommender systems, usually have metrics like NDCG or precision at K and something like that. But our case is that we are not evaluating recommender systems, but we are evaluating estimators that evaluate recommender systems. So we want to measure how well we can actually make these estimations. So in that case, you use standard metrics like mean absolute error or mean squared error.
Thank you. We have another question for you. How much data is needed to use off-policy approach? And are there cases when it is better to use A/B testing and vice versa?
In general, it really depends what kind of problem you have. It depends on 2 or 3 factors. One of them is how many actions you have. Under the action, you can understand like specific items. So if you are Amazon, let's say, and you have billions of products you can recommend, you have a lot of actions you can take. So, and you know, from standard machine learning, every action is new feature and your space gets bigger and bigger and you need exponentially more data. So in general, in cases where, and my specific case, where I go over lists of actions and those this space combinatorially expands, you need to have a lot of data with the current estimators to do it. So, but in quite simple cases, you could do it with, let's say, n squared data, where n is the number of actions you have.
Thank you, Maciej. A question from me for Ivana is that you said in your presentation that by making the AI understand multimodalities and their context, we can be one step closer to generative intelligence and closer to operational efficiency and improved decision making. What does that mean in practice? Where can we see the possible applications of that?
Okay, so imagine a world where you would come to a doctor and have a CT or MRI scan done. And then within a second, an automated doctor would generate a description of a scan and diagnosis based on previous records of yours and thousands of scans of other people. You could have answered your questions about your health, and you don't have to wait there like hours like you could now. This could be how implemented multimodal processing can look like in the future. So I would really like to be there when this is working.
Me too. This sounds really effective. Last question for you both very shortly. Is your work publicly available, e.g. on arXiv with an X?
I can answer probably. So the output of this research is probably just the beginning. And for me, it is continuation on which I'm building on now. So my target is, for example, to publish it on Rexis. So it will be available in some other forms on conferences or workshops probably in the future.
Thank you very much. I don't know if it applies for both. Ivana?
Yes, I would say also I'm at the beginning of my research, and I hope in the future it could go somewhere. But right now, it's really just a replication, we can say.
Thank you. Thank you both. Let's move on to our next batch of PhD students whose research topics are closely connected to the industry this time. You will watch the presentation of Patrick Goldschmidt, who is fighting against cyber attacks and trying to stop hackers. Patrick's supervisor is Daniela Huda, which you heard in the beginning of this event, and his talk is titled Machine Learning Powered Cyber Attacks Detector. The same supervisor, Daniela, is also leading Martin Mocko, whose PhD topic is equally from the field of machine learning in security, but through the lenses of deep clustering models. Whereas our first students from this group, Petr Pavlik, is working on a topic that is very familiar to all of us, but I will not reveal any more in advance, apart from the fact that Peter focuses on intelligent data analysis and his supervisors are Viera Rozinajeva and Anna Buezedin. Let's look at the videos, and please do not forget to ask all the questions that will spark in your mind during the presentations using Slido and the hashtag KInIT PhD.
An important email. You have been busy past days, so you let everything on the last few minutes before the deadline. You finish writing, give it a quick check, and hit the send button. However, the wheel keeps spinning and spinning, and after a while, you receive a message that the sending had failed. The email server is not responding. You panic, click the button again, but nothing happens. You shout, scream, swear, plead, but still nothing. You just miss a deadline and an important project will be assigned to someone else. Later you found out that your email provider had been down due to a cyber attack. But couldn't they prevent it somehow? And that's where I step in. Service providers nowadays are literally drowning in tons of data. Analyzing them and coming to any relevant findings may thus become quite a challenge. In my research, we utilize two techniques, data mining and machine learning. Data mining is used to extract interesting information and statistics from the data. Then, we apply machine learning techniques such as neural networks to detect any unusual activity on the computer network. My past months at KInIT were focused on exploring machine learning models for traffic classification. In this scenario, we trained our models to distinguish malicious patterns in the network data. In other words, our models were trying to predict which traffic is good or bad according to their communication characteristics. These steps may help us to detect or prevent possible cyber attacks or their attempts. Therefore, I stand at the very beginning of the cybersecurity chain. Our algorithms will detect threats floating around and hopefully make the internet a better place.
COVID-19 is not the only virus that has been spreading fast throughout the world in the last year. In fact, we saw a new record high in the total number of malware infection samples that has been spreading throughout the internet. Cybersecurity companies have been under a great pressure to catch all these new variants. To catch them effectively, malware security experts cannot look at every sample that they come across. Most of the new malware samples are created by reusing some of the old code while adding slight differences. Therefore, the experts need to focus on the samples that are the most unique and have the highest potential of being malicious while being still undetected by their systems. This is where my PhD study at the Campbell Institute comes in. One of the ways that we can detect new malicious behavior can be done by clustering. If we cluster incoming binary samples, we can filter out the malicious behavior from the normalcy. When done correctly, malware samples will end up in their own little bubbles, i.e. the clusters, where they only see their counterparts. This also holds true for the normal software. In my research, I focus on how this clustering can be improved to achieve new state-of-the-art results in grouping similar samples together. This can greatly help malware security experts to identify and pick out which malware samples they should look at further. In my work, I'm trying to incorporate the recent successes of deep learning by utilizing deep clustering models. There are a class of unsupervised methods that utilize an end-to-end neural network framework. Such a framework is then able to provide us with a clustering assignment. The main advantage of these methods is that they are able to create an internal latent representation that is optimized specifically for the clustering task. This is a drastic change from the previous approaches, where malware experts had to try out many different representations to see which one provided the best clustering quality. Utilizing this class of methods in the malware domain is rather new, and it comes with its own set of challenges. We need to be able to train on at least a few millions of samples to capture information about all the different malware variants. We also need to be able to create tens or even hundreds of thousands of clusters. Even evaluating malware clustering quality can be considered a research task on its own. That is why I'm thankful for the cooperation we have with our industry cybersecurity partner, ESET. By joining our forces together, I hope we can help suppress the spread of malware even further.
Many of you have probably been in this situation before. You are driving your car, the snow is falling, the road is slippery, and the pace of traffic slows down to a crawl. In fact, it's become a bit of a running joke in Slovakia to make fun of the road maintenance services and how they should have prepared better almost every time a heavy snowfall happens. Now, you might be asking, what does this have to do with artificial intelligence? Let's imagine you are in charge of applying road salt during winter as an example. While applying road salt to all the roads all the time would undoubtedly help the drivers, not only would the cost be enormous, excessive use of road salt speeds up the corrosion of cars, compromises the structural integrity of concrete, and also causes severe environmental damage. Obviously, we want to minimize its use. If we apply road salt to the surface before it freezes, we can prevent it and only use around 1/3 the amount we would need if we were to apply it after. Therefore, predicting the road status and choosing the optimal strategy is crucial. That's why the focus of my research is winter road maintenance, using new approaches to predictive modeling and optimization algorithms with a focus on machine learning and artificial intelligence methods. Together with our industry partner SoftTech, we aim to make the winter commutes safer and faster for the drivers. We are looking for novel ways to improve the current winter road maintenance systems using data analysis and machine learning techniques with a focus on deep neural networks. We'll be using data from custom IoT devices located all around Bratislava and weather data from Slovak Hydrometeorological Institute. Based on these, we will develop models to minimize the human labor and material costs and also reduce the environmental impact of the maintenance services. In this project, we are focusing on 3 main research areas: providing a more accurate model of the current state of the roads, improving the forecast and simulation of the future state of the roads, and developing a way to optimally manage the available resources. As a first step, we chose to improve the short-term precipitation forecasting based on recent radar data. Data-driven approaches are great for this task. They can outperform even the most complex numerical weather prediction models because they can produce an output almost instantly, and therefore they can use the most recent data available. To handle this task, we developed a convolutional neural network with unit architecture that produces a forecast 30 minutes into the future based on recent radar observation. In the example output on the right side, you can see that the forecast we were able to produce matches the actual movement of the clouds on the left side. This model shows promise, and it could help the dispatchers make better proactive decisions in the future and eventually even serve as an input to a fully automated management system. The prediction methods we develop within this project will be verified in the road maintenance domain, and we hope they will also be applicable on a broader scale in other domains as well.
Thank you all. We just saw some really interesting approaches to the threats that we all know, either cyber attacks or the snow in Bratislava, which is a threat in itself. So let's go to the questions right away. All three of you are here with me. I have already some questions piling up in Slido, so I will start with that. First are the questions for Patrick. Patrick, what kind of data were you working with?
I basically put the publicly available data sets. There were, I think, 4 or 5 to them that that anyone can download and test their machine learning models and other techniques. And these data sets contain many types of intrusions and are generated synthetically or contain real traffic as well. So these are kind of data I've worked with, but we're also planning on some real data from our industry partner. So that will be a future for me.
Thank you. We also have another question for you. Can you describe how would you like to fight against the cyber attacks? Is it detecting that something is happening as soon as possible? Unmute yourself, please.
Sorry. Well, there are several techniques for that. Of course, the one is the prevention, that we want to prevent the attack at the first place. And what I am doing is the detection. So when the prevention fails, then something needs to be detected, that something is happening. And this is my area of research. And of course, as soon as we can detect it, the sooner we are able to take any precautions. So this is my area, the detection, of course, as soon as possible, but there are so many others. But of course, prevention is also a very important step in cyber attacks defense.
Thank you, Patrick. Peter, question for you. What do you think will be the most impactful result of your research?
Well, in my opinion, the most impactful result of my research will be reducing the environmental damage of the winter road maintenance. As I mentioned in the presentation, the use of road salt is very damaging to the environment, and also we can optimize the road maintenance systems. We can also reduce the number of rides that have to be taken by the road maintenance vehicles, which also decreases carbon emissions.
Thank you very much and good luck with that. And for Martin, we have a question. Martin, what uses do you see for the deep clustering when dealing with security, and with what way can it help?
Thank you for the question. So basically, the use that I see is there is a possibility that we can improve the clustering performance of the general clustering performance on benign samples. Basically, how I see it is that previously researchers were working with some feature set that wasn't optimized for the task of clustering. It was just some feature set that, okay, it was probably like working pretty good for the task of malware detection. And then you take this set, maybe adjust it a little bit, and then use clustering for it. But with deep clustering, the methods tries to optimize the internal representation, the latent representation, to better suit the task of clustering. So it is possible that we can improve, for example, the homogeneity of the clustering or the completeness or metrics such as this. And in the end, this can mean that we will end up with clusters that are basically more pure. So maybe you can see only a cluster with pure malware or pure benign samples. And this can help effectively identify new malware sooner.
Thank you very much. And the last question very quickly, so we can move on, is for everybody. Which machine learning algorithm or algorithms, this is a very hard word to say, did you use? Whoever wants to start first, perhaps Patrick.
Sorry, well, I used several techniques. The neural networks were the most prominent, but also decision trees, random forests, and so on. So I tried multiple techniques for detection of intrusions and basically chose the best one. So that was my approach.
Thank you. Peter?
For my task of precipitation nowcasting, I used also a neural network, specifically with UNIT architecture. Maybe the next step will be using GAN type architecture, since those proved to be quite useful for this task as well.
Thank you. And Martin?
So for the task of the deep clustering, basically I use an algorithm that is called deep embedded clustering. It is a method published in 2016, and it consists basically of a stacked denoising autoencoder that is then connected to some other form of neural network that can predict the clustering assignments. So basically it is all just new neural networks.
Thank you very much. For the sake of keeping it short and sweet today, let's move on to our last two students who in their doctoral research cooperate with international projects on quite a large scale. And I would like to remind you all that if you want to ask any of our students more questions, go more deeply into their topics, you will be able to join separate discussions with them after this event. There will be a link either in the comments under the Facebook live stream or in the subscript or in the or under the video on YouTube. I don't know where you're watching us, but you will have a link there and you will be able to connect these separate rooms and talk more. So for now, to our next two students and the last ones of this showcase, Jan Czegin will unveil what the famous actor The Rock has in common with false news detectors. But more seriously and more importantly, he will tell you about adversarial examples generation with human in the loop. He is doing his research under the supervision of Jakub Šimko and in cooperation with an external mentor, Petr Brusilovsky from the University of Pittsburgh. And the last but not least, our 7th PhD student, Branislav Pecher, will show you why biking will not help you ice skating and what it all has to do with the stability of machine learning with limited labeled data, on which he is working with his supervisors, Maria Bielikova and Ivan Srba. Let's watch the videos.
Let's start by considering a piece of false news information. For example, people should be avoiding China to not contract COVID-19. Now this piece of information is fed into a false news detector. The job of this detector is to classify if a given sample is either true or false. Let's consider that for the sake of this example, the given detector is successful and correctly predicts that the given piece of information is false. So what would happen if we were to tamper with the given sample? Let's say that we change it to people should be avoiding the most populated country to not contract COVID. Now, if we change it this way, the detector might have real issues with correctly predicting if the given information is false or real. We call these kind of samples adversarial. They help us in revealing the given weakness of a model. We might either use it to attack a model or increase its robustness by creating these samples and then using them as training data. Now, as good as this is, we might ask ourselves, how do we collect these data? There are multiple ways one could go around this, but we consider one of them, a game. In here, we have human players that, given a piece of false information, are interacting with it. Let's consider the same from the previous example. So what could the player do? For example, he could change China to CCP. He could change the tense of the given sentence, or add a non-meaning altering phrase at the end. All of these are potentially adversarial samples. If any of them tricks the given model, the player is awarded points. In total, we have collected 125 samples, out of which 64 of them successfully tricked the given detector. Now, as good as this is, it's kind of expensive. We don't want to use human labor for this task, as it's really not reproducible. So what can we do about this? Well, for one, we could use the identified player strategies for an automated adversarial generator. The job of this generator is to automatically produce these adversarial samples that are fed as training data to the given detector. As such, we will produce an even better false news detector.
COVID vaccines contain microchips that are used for tracking, or COVID vaccines may cause changes to the DNA, or vaccines cause autism. You probably heard all these claims, as other 4.5 billion people every month. However, all of these claims are false information that may cause problems in society. The amount of misinformation in the world is so high that each of us encounters at least one misinformation every day. Disproving all of them is infeasible for fact-checkers to do without effective tools for automation. In my PhD studies, I'm working on making the work of fact-checkers easier using machine learning as a part of international project SEDMO. One significant problem we face is the lack of labels, as each fact-check takes days or weeks to do. Typical machine learning uses tens or hundreds of thousands of labels for training, but we need to use only tens or hundreds of labels spread across languages and tasks. To deal with this problem, we employ machine learning with limited label data that can achieve good transferability between tasks and datasets. We can compare it to the way human learns today. If I already know how to skate on roller skates, I can use this knowledge to learn ice skating faster. However, there are many factors that influence the success of these transfers, one of which is similarity. If I already know how to ride on a bicycle, it will not really help me with ice skating. Applying this to our domain, where we deal with text and languages, transferring something from Czech to Slovak is easier than transferring something from English to Slovak. Another significant factor is stability of the machine learning. As we deal with limited data, the effects of uncontrolled randomness can significantly influence the outcome. We can imagine this with cooking. Using the same 4 ingredients, the order in which we add them to the meal will significantly influence the final taste and quality of the meal. So, in this work, we focus on investigating the factors that influence stability and the success of transfers in machine learning with limited label data to better control their effects. Knowing and controlling these factors will help in developing successful machine learning tools that automate some of the tasks required for fact-checking, such as identifying claims in articles or finding sources for proving or disproving these claims, while only utilizing the small amounts of labels available.
Well, we saw games, we saw sports, and we saw some serious science here. Thank you both for your presentations, and I'm really glad that I already see the questions again piling up in Slido. So the first question is for Jan. How quickly can the false news detector adapt to new topics, for example, like war misinformation, which is a very current topic right now?
Yes, thank you for the question. It's quite a good question, and it really depends on the given false news detector that we are using. There are approaches that are built to deal with or are built to adapt to even small samples of data, and it would really depend on what kind of model we are using and what kind of data it's currently being fed to. We could use, for example, tweets, comments, even social history and other things. So it really depends, and we will explore it in our research, how well different models can adapt to these adversaries.
And are you focusing on this information in English or also in other languages?
The current amount of data sets or the current data sets are mostly built in English, considering false news detection. So we are working with English, but we believe that this approach could be as language agnostic. One way would be to generate small samples of adversarial samples in other languages, or transfer the given model and adapt it to a different language. All of these are options that we may look into future.
Thank you very much. Branislav, what is the collective goal of SEDMO?
Okay, thank you for the question. The overall goal of SEDMO is to implement the hub against false information in Czech Republic, Slovakia, and Poland. They will perform some activities such as producing fact checks, increasing media literacy, and most importantly for us as KInIT is researching and developing AI-powered tools that automate some parts of the fact-checking process and thus making the job of fact-checkers easier. Well, that is the short answers. And if you want to know more, you can visit our project page about the SEDMO project.
Or come to the discussion with you, the individual one after this live stream.
Yes.
And one more question, what is the desired result that you would like to see at the end of your own research activities?
Okay, so the desired result is to make some advancement in solving the problems I'm focusing on. So advancement in learning with limited label data and its application in the misinformation domain. And I hope that my research will make the development and use of some of these approaches more efficient and allow for development of better tools.
Thank you, Branislav. We have one more question in Slido for Jan, and that is what model and what data did you use?
Yeah, so the data used were, or the title of the paper is Fighting an Infodemic COVID-19 Fake News Dataset. These data were collected at the start of the pandemic during 2020, and they consist of tweets. The model was an SVM built on a TF-IDF that was used as a baseline in this paper.
Thank you both, and thanks really to all of you for these excellent presentations and for our little discussions. I would like to thank the audience for your questions and interests, and I really hope that many of you want to continue. You can continue with individual deeper discussions with our doctoral students. Please follow the link that is in the comments under the Facebook video, or even some of you who were invited have the link in their email, and there you will find on the link a document with the links to all the separate Google Meets where you can join and where we will continue. So I would like to also thank you, HubHub, in the end for the space again that we could record in. Big thanks that way, and enjoy the rest of the day. This video will stay on Facebook as well, so you can come back to it later if you maybe joined us later and would like to see the beginning. So it will be possible. Have a nice rest of the day, and thank you very much for your attention.